Okay, in this one, it says we've taken a random sample of 20 female college-aged dancers. So n is equal to 20. And it says the sample mean height is 63.3 inches. So my x bar is 63.3 inches. And it says the sample standard deviation, my s, is 2.17 inches. It says assume that the distribution of heights is normal. It says create a 95% confidence interval. So the formula for the confidence intervals, we put the mean height, I keep writing y, but our x bar, the sample mean x bar in the center, and we go plus or minus some critical value t star times the standard error. So in this case, my sample mean is 63.3, and my t star, I go to that table, and here it's asking for a 95% confidence interval. So I'm going to look up 95% confidence. And how many degrees of freedom do I have? Degrees of freedom is n minus 1. So here I have 20 dancers measured, so 20 minus 1, 19 degrees of freedom. So 19 degrees of freedom with 95% confidence is 2.093. And I multiply this by my standard error. The standard error is equal to s divided by the square root of n. So in this case it's 2.17 divided by the square root of 20. So I'm going to calculate this part over here, 2.093 times 2.17 divided by the square root of 20. And this part comes out to be 1.02. So I have 63.3 plus or minus 1.02. So 63.3 plus 1.02, that gives me the high end and the low end on my confidence interval. So I would have 64.32, and 63.3 minus 1.02 gives me 62.28. Alright, so this is the our 95% confidence interval. So I would write I am 95% confident that the population mean, so in this case, what is the mean that we're looking at? It's the population mean height of female dancers. Is between 62.28 inches and 64.32 inches. Okay, so any one particular dancer could be outside of this range, but when we look at the entire population and calculate the mean of the entire population, we're 95% confident that that mean is going to be between these two numbers. Okay, if I wanted to make a 99% confidence interval, I'm still doing x bar plus or minus my t star times the standard error. All the numbers are the same except the t star. The t star has now changed to be a 99% number. So if you look at that table, I no longer use 2.093, I'm going to use 2.861 times my standard error, which is still going to be 2.17 divided by the square root of 20. And my x bar is still 63.3. So this becomes 63.3 plus or minus, and now I have a new number to calculate, 2.861 times 2.17 divided by the square root of 20. This gives me plus or minus 1.39, or I could just, I'm going to just round off to 1.4. So I have 63.3 plus or minus 1.4. So 63.3 plus 1.4 gives me, on the high end, 64.7, and on the low end, 63.3 minus 1.4 gives me 61.9. Okay, so I am 99% confident that the population mean height of female dancers is between 61.9 inches and 64.7 inches. Okay, so which interval is wider? The 95 or the 99? The 99% confidence interval is wider. Okay, so here the 95% we're going from around 62.3 to 64.3. And for the 99% confidence interval, we're going from 61.9 to the 64.7. So the 99% confidence interval is wider. And the reason is, if we want to be more confident about capturing, if we want to be more confident about, quote, capturing the population mean, we have to make our interval wider. It should be wider.